How are you, everybody who is watching this video? I would like to welcome you into this fantastic moment of learning the beauty of higher engineering and scientific mathematics. Okay, so my name is Sir Olenjolai from Tanzania, eastern of the African continent. I would like to welcome you, whether you are international viewer or a national viewer, in our online platforms where we used to train students who are undergraduate students, whether that's they are in Tanzania or they are in other continents or in other parts of the world, as long as they are learning undergraduate studies in engineering or scientific area. Of course, so you are warmly welcome into our online undergraduate, since this is the abbreviation Undergraduate Polytechnic Institute of Tanzania, square bracket Olenjolaim. Simultaneously, we'd like to welcome you into one of our official YouTube channels that called the Online Undergrad Polyinstitute of Tanzania, in square bracket Olenjolaim. So, I would like to remind you quickly, just to spend a few minutes to remind you the vision that we have in this platform, so that every time you have to make sure that you grasp it and remind and you refresh your mind so that we'll be together from step to step. This is the vision that the father, the manufacturer, who has given me the own of this program, because I've been employed by the God who lives forever and ever, my Alpha, my Omega, my God who is Almighty God. He declared these visions because without visions, people perish. So without visions, Olenjolai will perish, with his own programs of Online Undergraduate Polytechnic Institute of Tanzania. So this is the vision that is revealed in my mind, that he gave me an assignment to prepare, incubate, even that just prepare, to incubate, to train, to teach some group of undergraduate students who are ready to take the classroom instruction in engineering mathematics or scientific mathematics, combining with the knowledge of the fundamental, or we call them core subjects, or yes, core subjects. I mean that it may be in engineering or in any engineering course or scientific course, combining with the knowledge of Word of God from the Bible in order to solve real life problems. We don't go to the undergraduate level in order to have certificates. However, that some of the students, they might have such kind of the definitions, but the fact is we used to go to undergraduate level and even used to get educations in order to use it effectively to solve real life problems. So the main objective of these platforms, of these programs, is not to have students to pass the exam. The main objective is to teach, means that to change, it means that to teach our students to think differently on how they can use the classroom instructions combining with the Word of God, that is the light, okay, and the truth, in order to solve real life problems. So our main objective we would like to see, we'll be happy to see our continuing undergraduate students who solves problems, real life problems, even the small problems from the community, from the families, from the clan, from the village, from the street, from the district, from the city, from the country. So it means that I like students who think on how to solve real life problems, because from there we become wise, we become successful in life, and even we become meaningful, and will be dying empty, and we have to conquer the grave by pouring out ourselves on everything that God has planted as a seed. So that's the main visions, and that's the main objective of this platform. We have some specific objective. One of them is we like to help our students to pass the continuous assessment, tutorials, means to solve tutorial questions, to pass the test 1, test 2, the annual, the final exams, or we call it in some of the institutional university exams. That's one of our specific objectives. Our second specific objective, to help our students also to understand and love higher engineering and basic mathematics, higher engineering and scientific mathematics. The third specific objective also, we like to see our students graduating with high pass mark in higher engineering and scientific mathematics. That's not the case. but also that our first specific objectives would like to challenge our students in order to see the real applications of these concepts of mathematics in their engineering or fundamental engineering or scientific core subjects, so that they won't study these concepts for leisure, or they won't study in order to accomplish the syllabus, except and so forth and so forth. So that's the key points, and those are some of the specific objectives that you would like to have. You have to make sure that you have your scientific calculator for all the competitions. We'll be having some competitions, and then in this online institution, polytechnic institution, we have some departments, and one of the departments is called the Departments of Higher Engineering and Scientific Mathematics, and then also the course that we have today is called the calculus. And then we say that calculus, and this is chapter 1. So we have chapter 1, the theory, right? The theory or theory of limit. And this is lecture 4. We have already taught lecture 1, 2, 3, lecture 0, 1, 2, 3, and lecture 0, 1, 2, and 3. And today that I would like to teach about basic rules of limit. Okay? And then this module or this course, it has been studied by the first semester of the first year. And also, in case that you want to offer God your free will in Thanksgiving, you may offer it through this telephone number 0759745331, so that he will be supporting the running cost for these programs, because it's very expensive. So get prepared to enjoy the beauty of higher engineering and scientific mathematics. So let us begin from the point that always I begin. This is the common point for me to begin, start with quick review. So remember that up to this moment, I have taught you the lecture 00, which is the general introductions of calculus, and also that I have taught you another lecture, which is lecture 01, which is the general introductions of the limit, and also I've taught you another lecture, which is called the lecture 02, where I taught you about the informal definitions of the limit, and even the formulas, and the formulas of finding the limits and applications of the informal definition. And recently, I've taught you about the lecture called the lecture 3, where that is problem solving or solving questions of informal definition, right? That's what I've taught you. Just to remind you some few concepts that you have to understand and you have to remember. We say that the general definitions of the limit of the function, we say that the limits as x approaches to a of the certain function, this is equal to r. And this formula is, or the limits will be existing, means that the limit L of existing if and only if and only if, okay? So that we say limit as x approaches to a bar of f of x, this will be equal to limits of the right hand side as a approaching to positive a f of x, this is equal to r. So that's the condition for the limit to exist. And remember that when we be dealing with limit of left hand side, this means that you're dealing with limit as x approaches to a bar. The a bar, remember that indicating that the limit is on left hand side. Means the value, we are approaching the point A from left hand side toward A. But also limits of right hand side, this is, we say that is given as limit as x approaches to a of f of x. We have to remember also there are some special functions, right? It means that when you're looking at the limits, we have some special function. And one of the special functions, if you do remember in the lecture 3, I presented to you about absolute function. So this absolute function, they have a special property, okay, absolute functions. And they left the homework 3, right? Homework 3, okay, homework 3, and let me do the correction. So let me do the correction. If you've done it, submit in the comment section, corrections of homework 3. So let me do the corrections, okay? let me do the correction. First of all, let me write possibly that this is your first lecture. Okay, but make sure to watch some other 4 lectures, lecture 00, lecture 01, lecture 02, lecture 03. Okay, so the question was stating that, let me do corrections and then start with today's concept. If f of x is equal to absolute of x minus 2, and then here we have x squared, then plus x minus 6, okay, then find what? Then find Roman 1, okay, find Roman 1 limit as x approaches to 2 positive, okay, of 40 of f of x, okay, and then Roman 2, let us find as limit approaches, as x approaches to 2 negative 2 bar, okay, of the function f of x, and then Roman 3, you have to find limit as x approaches to 2 of the entire function. And if you do this question, because this past paper, this is example 6, okay, possibly 6 or 7, something I think that is example 7, and it's a review of final exam, the final exam of 2017, okay, 2017. Okay, so that's why that you have the marks. So the questions was asking you that to evaluate these 3 limits. So before we solve this question, I would like Kirsty to do minor corrections in this question. Don't get confused about this plus on this side, because the plus according on this paper it has been written after number 2, and also this bar it has been written after number 2. You expected that to have 2 bar and you expected that to have 2 positive. Sometimes in the computer, because of the challenge when the teacher preparing the exam, it's a little difficult to have these notations in mathematics. So that's why that this is just the issue of typing errors. The typing errors, whether typistic that has made some mistakes, but the issue or the concepts you have to understand what has been asked. So let us solve. So we'll be following some steps on solving it. Okay, so the first step we say that the first step, this is absolute function and this is quadratic function. So the first step we say that let us factorize the denominator. Let us factorize the denominator. Our denominator is x squared plus x minus 6. Okay? So you have to think that what should be the number when you have a plus b is equal to 1, and when you have a times b is equal to negative 6. Okay? So it is 3 and what? It's 3 and negative 2. So 3 and negative 2. So it means that if you have 3, negative 2, you get 1. And 3 times negative 2, you get negative 6. So simply say that x squared plus x minus 6, this is equal to x, okay, minus 2x, this is equal to x squared minus 2x plus 3x, then minus 30, minus 6. See, the rate has now has been simplified. So if that's the case, we say that, because if you add this one, we still get x, okay? So if that's the case, we say fine, so x is common here, so you have x minus 2, and then we say that on this side 3 is common, we have also x minus 2. So the expressions in the parentheses is common. So again, that we collect this and this one and form the factor, okay? And then against this is common, we just take 1, x minus 2. So this, remember that this is equal to x squared plus x minus 6. Okay, so now it means that limit as, or we say like a function, a given function now, we can relate it as absolute of x minus 2. We have m there is absolute 8. And then here we have x plus 3 and x minus 2. Right? So remember that for the absolute, we use negative sign to find the limits of left hand side, because the absolute sign means the plus or minus of what is inside the absolute side. So negative will help us to find the limits of left hand side. Positive will help us to find limits of right hand side. So if that's the case that we say that this, you have to note that if you're looking absolute of A, this is equal to plus or minus A, right? That's the case. So if that's the case, you say that absolute of x minus 2, this is equal to plus or minus x minus 2, right? So this is the, okay, yes, this is the second state. Second state. Okay, do you enjoy the beauty of higher engineering and scientific mathematics? Tell me in the comment section below so that I will know. And then tell me that you're enjoying these contents from which country, from which continent, from which institution, from which college, from which university, from which city in Tanzania, from which district, from which one, from which village, from which street. Tell me whether you're enjoying from home, because these contents are very important for the lovers of mathematics. So if that's the case, now we say that if you be dealing with limit, the general limits, which is limit as x approaches to 2, and then that our function is, it has been x minus 2 absolute, and here we have x minus 2, and we have x plus 3. So simply this is equal to what? This is equal to limit as x approaches to 2, and then that on the numerator we have x minus 2, but plus or minus divided by what? X minus 2 and x plus 3. Okay, so we go for the third state. So the third state, we say that let us find limit of left hand side. And this means that we'll be answering from and to first, because that's the starting point that I told you. So to find the limits of left hand side, we have to consider the negative sign in what? Negative sign. So this is 2 bar in our inequality. So in our inequality, we have negative sign, and we have to ignore for this time the positive sign. So it is negative x minus 2, or negative open bracket x minus 2. Then here we have x minus 2, and here we have x plus 3. So if that's the case, this one and this cancel. So then we say that we have limit as x approaches to 2 bar, and then there we have negative 1 over x plus 3. So then remember that negative means 2 bar on the number line can have that like this. So this is 0, this is 1, and this is 2. So it means that we are moving from left hand side toward number 2. So you can use a scientific calculator, and then you insert these functions as I taught you in previous lecture, and then you try. What if x it is 1.99999? Okay, then what if x it is 1.92? What is x is 1.991? So you'll find that in all of your testing, and even if you draw the table, you find that in this case, limit as x approaches to 2 bar, right, of negative 1 x plus 3, this is equal to negative 1 over 5. So do your testing and do your confirmation by using a scientific calculator. And in case that also you don't have a scientific calculator, that will help you to understand and grasp different concepts in high engineering and scientific mathematics, and you don't have a scientific calculator like this or any other else, you can go to the description below and see how much does it cost you and what is the shipping cost you to Tanzania. Okay, so then that we say this is Roman 2, we say that limit as x approaches to 2 bar of ffx, in this case, is -1/5. Then here we are. Okay, so we go for the first step. The first step, let us find limit of right hand side. So when you find the limits of right hand side on the inequality part, we consider positive sign. So then we say that limit, because remember, if these two limits are equal, then the limit exists. Okay? Remember the condition. Limit as x approaches to 2 bar of what? Of plus or minus. And here we have to consider plus. We ignore the minus. Then here we have x minus 2 divided by x minus 2. And then times x plus 3. Right? So then simply we simplify these terms in this term. So you find that limit as x approaches to 2 bar or positive bar. Here we have positive 1 divided by x plus 3. So with this one, if you draw on the number line, it's just like this. This is the 1. Okay, this is 1. And this is 2. So when you're saying that as x approaches to 2, we are moving from right hand side toward point number 2. So the response will be, after you have too much trials, you'll get at is 1/5 but positive. Right? So you say that this was Roman 1, limit as x approaches to 2, right? To 2 of the given function f of x. This is equal to 1/5. Then the next step, which will be the fifth step of solving this problem. Okay, so you say that you compare left hand side and right hand side. Okay, compare. So if you do compare, you find that 1/5, or the first one, negative 1/5, this is not equal to 1/5. They are unequal limits. So because they are unequal limits, then we conclude that the limit of the entire function does not exist. Okay, so does not exist. So for this case, we say that limit as x approaches to 2 of our f of x does not exist. So even this also is a response. The limits of the functions as x approaches to 2 does not exist because the limits of left hand side is not equal to the limits of right hand side. Okay, so that's not what exists. So this is all about the corrections of example 7. I believe that you enjoyed, and I'd like to take you into the next step. So I have the subtitle there for the concept called basic rules of limit. You have some basic rules of limit. Why do we have these basic rules of limits? Basic rules of limit. So why do you need these rules? Because sometimes that you find one function is added with another, or is summed with another function. Or you can find that you need some of the concept there. So we say that rules sometimes that you find will be asked to find maybe find the limits of the functions. That function still has a product, or it has a quotient, or it has something else that's around. So in terms of the base rules of the limit, so we say that there are some rules. There are some rules that simplify there are some rules that simplify finding the limit of the function. Okay, so when we'll be studying about these rules, then you have to remember that. You have to say that let limit as x approaches to a of f of x, this is equal to L. And hence you say that if we can let a limit as x approaches to a but g of x, another function, is equal to capital A. Very important. So these rules have names, right? K is constant. Limit of sum. Limit of 40 of a sum. Limit of a sum. So how do we deal with this case? We said that given that find the limits as x approaches to a, and then this a is a combination, is the summation of the two functions. The first function is f of x, and then the second one is g of x. So it's the sum of the two functions. Yeah. How do we find the limit? Excuse me? How do you find limits for this case, right? So we say that first of all, we say limit as x approaches to a is equal to f of x. We let this one is equal to r. And then again have limit as x approaches to a, g of x is equal to m. So find the limits of the function as x approaches to a, and limits of the function g as x approaches to a. Okay, so is that the case now? We say that now we found limit as x approaches to a of f of x. I have to find the summation plus limit as x approaches to a, g of x. This is equal to our plus m. Okay, that's the limit of the sum. We have also limit of difference. Before I do the example, say limit of difference of the function, of the two functions. So in this case, that for instance, I've been given this situation. Okay, given that limit as x approaches to a, and hence the function is f of x minus g of x. How do we deal with this problem? So as I told you that you should do it separately and then do the arithmetic operation. So limits of a function f of x, just like that one, is given as capital M, and also like to know limit as x approaches to a of g of x. So according to what you have learned in advance, this is equal to R and this is equal to capital M. Right? So if that's the case, now we say that limit as x approaches to a of what? This as x approaches to a So this, we have to say that we take the limits of the function x, which is L as m. That's all. Minus. So take the limits of as x approaches to a of f of x. Okay, so limits of this one, this is equal to L minus m. So this is the principle. So let us solve a simple question. On these tables, on the first row, this concept is relevant for you. Okay, so example 8, you say that evaluate limit as x approaches to 0 of f of x is equal to cos of x plus e power x. So we'll be given a function, so we say solution quickly. Be given a function, and this is what we have been given. Limit as x approaches to 0, and then therefore summations of the two functions. So it's similar if you say that f of x, but most of them are f of x, that limit as x approaches to 0 of cosine of x. approach to 0 of cosine of x, and then we say that we have to find limit as x approaches to 0 of the remaining part. As x approaches to 0, and then she said that you have cosine of x. So we have also the next part is a power x. We know that our original function is cos of x plus e power x. So then this we are using the rule of 40 of sum. So then this is the cases. So you have to find limit of left hand side as x approaches to 0. And you have to find the limits of the right hand side. So for this case, if you find the limits of left hand side becoming 1, and also the limits of right hand side becoming 1. So this one, it means that just by instructions and also the user's calculator to prove. Then we have again another function, limit as x approaches to 0 of 40 e power x. Right? E power x. So this is e power x. If you plug a number near to 0, the answer is equal to 1. So therefore, we say that limit so this will be limit as x approaches to 0, cos of x plus e power x. The answer is equal to what? The limit as x approaches to 0 of cos of x is equal to 1. And the limits as x approaches to 0 for this part will be e power 1. E power 0, which is equal to 1. So the answer is 2. So limit as x approaches to 0. Okay, as limits as x approaches to 0 for this function, cos of x plus e of x, and this one we make it to 2. Then we have another concept we call the rule of sum. Rule of 40, limit of a product. How do we find limit of a product? Limit of a product. Products of two functions. Limits of product of two functions. Limit of a product of two functions. Two functions. So for this case, you may be given a function like this, limit as x approaches so you say that limit as x approaches to a, then you have f of x times g of x. And then you find that it's complex to deal or to find the limits of the product of the two functions. So you can separate and hence you come and you multiply the concept. So it means that you have limit as x approaches to r. Okay, of f of x. So this one means that this is the limit of f of x as x approaches to a. So limits of what? Limits as x approaches to a of g of x. So as you say that this limit is r, and that one is what is r. So let us see an example of this concept. Example 8, example 9. So the question asks you to solve or to evaluate this simple trig function. So limit as x approaches to 0. And then here we have products of the two functions, x and cot of x. So the limits of x times cot of x as x approaches to 0. Solution. You have to be careful in these types of the questions. Okay? First of all, so this is the first step. You have to recall that cotangent of x, this is the reciprocal of tan. This is x. So, but again, we say that the cot of x, this is equal to cot of x, this is equal to sine of x over cosine of x. Okay, that's the definition of 40 of that function. So it is the case, so limit as x approaches to 0, limits as x approaches to 0, and then we say that in the position of x we have x, in the positions of cot of x, this is vice versa. So sine of x, this is x, and then here we have cosine of x over sine of x. Okay, So in that case now, we have to see the techniques which can help us to set apart, to separate these functions, but with conditions, or with a good expectation. And this is the good expectation. So we go for the second step. So this is the second, we go for the second step. Second step here, we say that let us x approaches to 0. Let limits as x approaches to 0. Let limits as x approaches to 0 of what? Of two functions. The first one, xe over sine of x. And then another function, so the limit as xe approaches to 0 of cosine of x. So the relationship between the small value of xe and sine of the small angle. So simply it was like this, as x approaches to 10, right? As x approaches to 10, let us find the limits as x approaches to 10. X cut of x, right? So this now is equivalent if we say limit as x approaches to 10 of what? Cos of x, but here we have n of x over sine of x. Okay? So you see, so that's why that you are going to have two parts of the function as x approaches to 10. Okay, this as x approaches to 10, then you can say that 10 now to 10 0. So as limits as x approaches to 0, then we say that of cosine of x answer will be 1. And hence therefore you have limited in as x approaches to 0. Then what we have? So limits as x approaches to 0, right? Of what? Of x over sine of x. So we say that the steady state with a small angle, we say that sine of x is approximately to what? For small angles, for small angle, sine of x is for small angle x, sine of angle x up to x. So we say that for small angle x, so we say that sine of x is approximately equal to what? Equal to x. So approximately is equal to x. So in that the case you say that limit as x approaches to 0. Limits as x approaches to 0. Then here we have x and the sine of x for small angles. This is equal to xc. Then we say that for small angle sine of x is equal to x. So the answer for this case is equal to 1. Okay, so if that's the case, we say that we have that is 1, that's 1, 1, 1. So there we say that limit as x approaches to 0 of x equal to so limits of this one, this is equal to 1 times 1 equal to 1. So limits as x approaches to 0 is equal to 1. So that's the response. As limit as x approaches to 0 of x equal to of x is equal to 1. That's the rule of product. It's a rule of product. Okay, so it means that those are the sum of the rules, and I would like just to take you into the remaining rules. There's a limit of, or a rule called limit of a multiple. Limit of a multiple constant number. This will be number 4. Limit of a multiple. What it means of a multiple? It means that in this case, you say that, for instance, given certain function that a, and then you are looking for the limit as x approaches to a of f of x. That's a limit of 40 of a multiple. So, like that. But we say that also response here limits as x approaches to a of f of x, limit of a multiple. And then we say that we have k. So we say that given that f of x, or given this one, this is equal to it. For instance, that you have constant k. And the limits of this function you say is equal to r. So the response will be k times r, or times r. Right? The meanings of limit of a multiple. So it means that if this is the multiple of this function, it goes the multiple of the limit. Okay? Then number 5, we come and we say that limit of quotient. Limit of quotient. Quotient. So limits of quotient. Limits of quotient, you say that suppose that you give a limit as approaches to a And then that limits as x approaches to a. Limits as x approaches to a, and then we say that we have our f of x possibly that may be power 3. That is over what means that the entire function. So limits at this one, and then possibly that we have square. Right? We have a square like that. So if this is square, we say that this is similar to say limit as x approaches to a of what? Of f of x. So that's what we have to understand. And we have number 6. Number 6. I've just prepared the only so generally for this case, you say that limit as x approaches to a of f of x possibly, and then she said that this one is there is n power or m of what over n. So this will be equivalent to say that limit as x approaches to a, and then you have f of x, and this is m over n. So for that case, it means that we say that the limit now of f of x is r. So it will be r power m over n. So you have to look for the limit of this function. Forget about the powers first. Once you get it, then you have to make sure to get also this expression. Okay? So then now I'm about to finish this session. So let me give you a simple homework. So this is example 8, this is example 9. Is this example 9 or example 10? For a sequence. Somebody can check it. So example, this is homework 4. Evaluate limit as x approaches to 0 half times x Okay, so we say that we have to evaluate this one, and merited is 5/2. Make sure to do it and submit in the comment section. It's a very simple question. Just that you have to find limits as x approaches to 0 of half tan of x power 5/2. So this is the end of this session, of this lecture. It has been lecture 4, very interesting. I thank God who have been with me in preparations of this session. of this lecture, and I'm giving him all the praise and all the glory because he deserves. And I thank him also who has given me strength to teach you. And I thank you also for taking your time and joining me. I would like to welcome you into the session or lecture 5, when that will be buildings our foundations on top of you. So I'm praying for you, pray for me. Make sure to subscribe here before you leave or you go to the next video. And also make sure that you share the contents with your colleagues, with the different people. And then you'll find that you enjoy the beauty of high engineering and scientific mathematics. So may God bless you, and I would like to meet you in the next session, which is lecture 5. Okay, we shall be discussing more about that topic. So may God bless you and keep you, and see you in the next session.